Welcome, Robert.
On. OK, great. So I guess this cloud thingy has been a theme throughout adaptTo and even more so today. And well, Tomek has told you a bit about the grand scale plans for AEM. I will take a bit more boots on the ground approach and try to talk you through how we can take Apache Sling, like the current, what we have now, Apache Sling, the Sling starter, and mold it into an instance which plays nicely with containers and Kubernetes and, well, all that jazz. Now, I'm going to talk about cloud-native applications and what makes them a bit interesting in terms of management, deployment. Not too much because parts of it have already been said. I'm going to make a demo, a bit of a longer demo about cloud-native Sling, and then lay out some future plans. Now, it's interesting because everyone has an idea about what cloud-native applications are, but not a very clear one. So, like any good engineer, when I first start asking myself, OK, what do I need? What is actually a cloud-native application? I go to the internet. Now, Stack Overflow wasn't good for definition, so I went to Google. Now, I'm not saying there are 66 million definitions. I'm saying there are lots of them. So yeah, I needed to go a bit old school and actually open a book. Now, that took me back a bit down history lane, but eventually I found one which matches that cloud-native architectures, right? Sounded like precisely what I needed to read. So I skipped to the definition page because I don't like reading the whole book. And like the authors proposed these three pillars, they call it, of cloud-native architectures. The first one is using cloud-native services. And I put a little circle here because it sounds like a circular definition, right? If you want to be cloud-native, you have to be cloud-native. But what that actually means is that if you have an application which wants to do everything by itself, wants to do rendering, it wants to do persistence, it wants to manage how it writes logs, it wants to do scheduled jobs, it maybe does virtual hosting, whatever, right? You will have a hard time making this cloud native because the first idea of cloud native is to use whatever your provider gives you. So if, for instance, you're going to one of the big cloud providers like AWS or Azure or the Google Cloud, they already have lots of services for you. So you do not need to handle logging. You can put them to system out and then ship them somewhere where the cloud provider has that. They probably have managed offerings for whatever persistent service you're using. They give you ability to execute jobs. They can manage DNS for you. And once you do that and start having a smaller surface for your application, try to do less yourself and more, take advantage of what your cloud provider gives you. Now, that is the first pillar of having a cloud-native application. Now, the second one, and I'm quoting this verbatim, it was application-centric design. But what it actually means is 12-factor application. You know, that old, well, now old in internet terms theory of start up fast, be stateless, use environment variables for configurations, write logs to standard out, etc. Now that's another good set of recommendations, and that is precisely because they fit in the usage of cloud-native services. So it's a supporting pillar for the first one. And automation, well, first of all, automation goes everywhere, right? It's the new agile. If you say you're not doing automation, oh, you're still editing your JSPs with FTP, right? Everybody smiles politely and they slowly walk away. Now, it goes without saying automation goes. And it's even more interesting when you have these cloud-native services because it no longer is feasible to manually manage all of the dependencies, all of the deployments, or the configurations. Now that cloud-native is clear, the next question is, what is so interesting about managing cloud-native applications? Now, everybody seems to be in love with containers. whether we think they're good or not, or bad, or progress, or setting us back, they are the way people package applications these days. So now this is just a Docker file, so I can have something nice on the background while I speak. But I assume most of the people here have already seen something like this. Now, this is a slide which is like Bertrand's earlier, but it's missing the fourth step because I'm not there yet. So containers are typically managed with, if you want to do containers, you have to have a management system for them. Once you start going beyond 2 or 3 containers running locally on a single server, you need some sort of process that manages those containers for you. And today, whether you like it or not, whether you think it's good or bad, that application is called Kubernetes. Kubernetes is basically configured using YAML files. You heard Tomek talk about this a bit. I will not go into too many details, but for the demo, I want to just quickly prepare the ground. So the pod, which is the basic unit deployment of Kubernetes, is defined in a YAML file, and you can attach various metadata to it. But most importantly, you can say, hey, these are the containers I want you to run. And these are just Docker image names. This is Nginx, and please open port 80 for it. And if you want to talk to Kubernetes, you have a command line tool called kubectl, which interacts with the Kubernetes API server. And whatever Kubernetes can do, you do with this command line tool. Now here you see just a listing of pods. Usually run many pods in a Kubernetes deployment. And well, we'll be seeing a lot more of that in the demo. As mentioned before, Kubernetes does a lot for you. So besides managing your application, it's doing DNS. It manages storage for you, so you can point it to whatever storage you're using, whether you're using NFS or Ceph, or you're doing hosted deployments in Azure, in AWS, whatever. It manages deployments. You can roll forward, you can roll back, you can scale, and that usually works pretty fine and transparently. Manages secrets. So if, and that's a big if, you have your Kubernetes cluster set up, it can basically take care of all your deployment needs for you. Okay, so I'm done talking. Let me take my demo steps. And let's start going through them. Now, I'm going to start. So, this doesn't look all that nice anymore. So what I have locally is a Kubernetes setup with a couple of nodes. Now, if Bertrand told you that there is, okay, I need to start this again, sorry. All right, this looks better, I think. Right, so I have a Kubernetes set up with 4 nodes. And I have a very simple Sling project. Now, if I look here, oh, I don't want to see the target stuff. So I have a Maven project with a Docker setup, and it's based on the Sling provisioning model. It's not terribly complicated. So we basically have the Sling start Maven plugin configured here. And then one of the Docker file Maven plugins used to build the project. And I'm building an image that looks like this. This is taken for the artifact ID. And I give it a specific tag. The Docker file is, I think it's the one you saw on the slides earlier. So it's basically the same as the regular Sling Docker file. So I was preparing the ground yesterday when saying copy-paste is not a crime, right? And in terms of provisioning files, again, very simple. In here, I wanted to add sun.misc to the available packages because some libraries needed it. I have a patched Oak version locally to work around some issues that I hit. And in Sling, this is basically the Sling starter. Now, what is more interesting is the Kubernetes definition. Now, First things first, this is a deployment, which means that it basically manages multiple pods for me. So nothing special. I say, for now, I manage one. But spoiler alert, there will be more than one replicas later on in the demo. And I tell it that the container is named Sling, and this is the image that we defined in the POM XML. Please expose port 8080. Then we add a service, so it can be accessible by other pods in the same namespace. And then finally, we add an ingress route, which is a way of making a service accessible from the outside. So deployment, service, ingress. And in the end, we have something like this, right? It's the Sling starter. It's not running on localhost. Yeah, not really visible, but it's a Sling running on Kubernetes. Now, there are a couple of things we can, how should I say it, optimize. Yeah, that's a good neutral term about this deployment. Now, one of the things which Kubernetes gives you is the ability to access logs on a pod. Right, you have this nice command, kube-control pods, and you have everything that container logs on system out. However, I realize that there are not too many logs here, right? At some point, it ends because the default logging configuration from Sling kicks in. Now, we could go on the container, go to file system, look at the request log, access log, but that's not terribly cloud native, is it? So what we do is make a little change. I will apply it first, and then I will show you. So, well, the first part is just bookkeeping, right? Change the tag and the corresponding change in the POM XML. And then what we do is simply reconfigure the log manager of Sling. So we say that the file is empty, which means everything goes to system out. And if you had to do with this before, you will notice that there is no timestamp. So let's see, has the deployment happened so far? Yeah, we notice that it's like 33 seconds, so it's a very new deployment. If I try to look at the logs, I see many, many logs, which is fine, so the repository started up. And the reason that I removed the timestamp from the Sling log is that Kubernetes records it anyway. Now that the logs are shipped to system out, we can do something there with them. Now, there are many ways of doing this. Tomek showed you something a bit different with sidecar containers. There's no right way, but what we can do right now is deploy a bit of an infrastructure on it. So we have every node is running something called a fluent bit, which is basically a log forwarder. And then they ship all the logs to an Elasticsearch instance, which we can access using Kibana, which is basically a front end. Now, if I go to, this is the Kibana dashboard that is running on my Kubernetes cluster. And if I go look for something like repository startup thread, yeah, I can see that these log entries were just shipped. So I have a central place where I store my logs for all of Apache Sling, for all my, oh, sorry, that's not what I meant. Now, if the good part is that basically this stores everything. So I performed a couple of refreshes, and if I look for starter HTML, I see the request that just came in. So a nice way to aggregate all the logging that happens in your Kubernetes cluster. Now, if we look, let's take a look again at the Sling pods. Sorry. You see this ready column which says 1 out of 1. So what that means is that this pod has one container and, well, that container is ready. And Kubernetes uses this for multiple purposes, the most important of which is to manage deployments. You do not want to start serving requests with a pod that isn't ready. So let me open another. Okay, this isn't going well. Let me do it like this. So if I want to run here a very simple check to see if the Sling starter is up. Oh, no, it's not that one. I'll just wait for it to time out. All right. So we get a 302 response. That's the important part. Now, if I delete this pod, because it's a managed deployment, it always says, hey, keep one pod. I will delete this pod and then list what happens, continue to list what happens to the Sling pods. And if everything goes right, then I should have no gaps, right? So if I get a 404 not found that is coming from Sling, and then a 503, and then another error. All of this, even though Kubernetes is telling me that the pod is running. Eventually we get the 302 found, which means that Sling is up. So why does that happen? Let's take a look at the next change. Kubernetes has something called readiness probes. So the important change here is that we define one for Sling and say, hey, just access the root path on port 8080. Start looking after 15 seconds and then check every 5 seconds. And the good part is that we already have all the infrastructure behind. In Sling, we're using the Felix health checks that take care of sending an appropriate status whenever this path is asked for. The rest is just bookkeeping. But if we don't tell Kubernetes how this happens, it will not know. So I'm still having these. I'm having a watch on what happens with the Sling pods, and let me apply step number 2. So we see a new container is pending. Now it's container creating, running, but it's not marked as ready. It's 0 out of 1. And if I access the Sling starter again, the old instance is going to come back with a 302 response. So there is no problematic transition. And now in some seconds, we should see that the new one is up and the old one is being terminated. Thank you so much for your service. So that was the readiness part. Now, the current setup has a very small flaw. I mean, I don't think it's huge, but if you delete the pod, it loses all the data. Now, you may see that as a problem or not. For demo, it's definitely not a problem. Of course, we're using the default segment node store and no volume for it. So I could show you how to create a volume so that the data is persisted between containers, but I think it's a bit more interesting to prepare the way for scaling out and show you a MongoDB a document node store plus a shared data store. So I will apply first to save a bit of time, and then let's see what happens here. So the first change is that we have this environment variable. We are still, this is too high, isn't it? We are still using the Sling run mode, so we just say, please use Oak Mongo. And then everything is picked up. We have a volume. Each pod has a volume here at /mnt data store, which will hold the share file data store. Of course, we need to tell Kubernetes where to give that from, so we give it a persistent volume that has 10 gigabytes, should be enough, and has a policy of read-write many, which means that many pods can read from it and many pods can write to it at the same time, which is precisely what we want. This is bookkeeping again, and I'm configuring Mongo to use the document node store service with a custom URI, so it's not using localhost, it's using a DNS name called Mongo. It's using a custom database name, a custom blob store, which is defined here below. Right, and if I look at all the pods, I can see that we actually have a Mongo pod, and we also have a Mongo service, so that Mongo service is what Kubernetes provides as a DNS entry. So that's why we're using it. Now, you may take my word for it that it works, or we can take a look at the logs. Right, so it says here, connected to database Sling starter and various document store logging information. Okay, good. So we have some information about our system, but it would be nice to see how it is actually performing. You want to see, are your requests slow? Is your disk filling up? Is your cache hit rate the right one? And usually you do this by deploying a monitoring system to your Kubernetes cluster, having information being scraped or pushed to that monitoring system and then exposing it to the users. Alerting, you may want to do that as well. So for this demo, there are many options. I choose a system that is based on Prometheus and Grafana. Let's apply this first. And if I want to take a quick look at the system, it is basically running some agents. They call it node exporter. So one agent runs on each own node and gathers all of these performance metrics for the cluster. The Prometheus server is the one that actually holds the data, and then Grafana is a friendly front end for us. So if we want to benefit, we have some annotations. So they are just additional data for Kubernetes. And this one are read by Prometheus. And we're saying, OK, please scrape metrics, please gather metrics from this pod on port 8080. And by default, Prometheus looks at the context, at the path metrics. And Sling does that with the changes that we did. And for that, we had to deploy a couple of support bundles from Prometheus and a small bundle that just bridges between the Sling metrics that we gather and the Prometheus ones. Now I can. So this is Grafana. It's a dashboard engine. So Prometheus stores the data, but Grafana actually makes it nicely usable. And you can have generic statistics. So this is one of the default ones, and it shows you how the CPU is used, how the pod memory is used, and a hint, not Sling is using the most memory, which is nice. But the most interesting part, of course, is creating your own custom metrics. So we have the Sling metrics, and here we have like a sample dashboard, and you have how many oak sessions are active in your cluster. Do we have observation events? What's the cache hit rate on the document node store? Do we have any running Sling jobs? The errors versus total requests per second, and sort of a heat map on how much time your requests take. So the brighter the color, the higher percentage of requests are served from it. So this is like the 5 millisecond bucket. So there's a number of requests being served in under 5 milliseconds. And you can see some requests here are served between half and 1 second. Now, if we want to pump some data into it, we can, no, I wanted this one. Just send off 1,000 requests and hope it copes. And if I take a look at the last 5 minutes as opposed to everything, well, we can already see some changes coming in real time. So the number of requests has changed. We haven't changed in observation events. OK, that's interesting. But anyway, now we have a nice way of monitoring our metrics for our Sling deployment in Kubernetes. Now, this is my favorite. This is the magic sauce. We tell Kubernetes, just a one-liner, change from 1 replica to 3. And well, hopefully that still works. Did this morning. There are no other changes. Oh, yeah, I deployed another bundle just to make it clear that the requests are hitting different systems. So let me go back to this one. Let's see if it's still, yep, we added system information, and this is going on this particular host. Now, I forgot to show you something. We currently set sticky sessions. Now, there are two reasons for it. The first one is that login doesn't work. Now, in AEM land, we have an encapsulated token for security. We have no such mechanism in Sling. So the login sessions are not propagated correctly. And the second one is that when you're using the document node store, you have a background sync. So changes happen on node A are not instantly reflected on node B. So it's a, let's say, suboptimal experience if you create something, refresh the page, and it's not there. So for that reason, sticky cookies. Now, let's see if, well, the Sling pods are coming up. You see there are already 2 of them. The third one is starting, and you will see they have different ages. So Kubernetes starts them in an orderly fashion, one by one. By default, doesn't just hammer. But let's try and do, you'll have to take my word that this is a correct command. So we can see that we are being sent on different hosts. 47, 44, 36. So there are currently now 3 Sling instances serving requests. I will apply the last step now. So we have scaled out, but at some point we need to take a look at the application and see that this is basically a static page, right? There is some content here, some logos, some resources, and there are 2 blocks that are dynamic. The first one is this session, which is actually rendered via Ajax. You do a JSON call, and then you populate. So this is fine. This one, on the other hand, is a regular Sling component, and it cannot be cached as it is. So I have applied, you probably know about Sling dynamic include, so it allows you to generate server-side includes, server-side include, well, as a code snippets in your output HTML so that it can be cached and then interpreted at the edge. So first step, I asked Nginx to enable server-side includes. I have added the Sling dynamic include bundle, the latest version, and then activated this configuration. We said, well, it's enabled. It's for the following resource type, which is precisely my component, for this path, and generate server-side includes. And just to make sure it works, I added a comment. Now, to be honest, I'm not going to show you benchmarks because they're exactly the same. There isn't a lot of performance gain because this, well, it's a pretty lightweight page. But if I go here, I see that Sling dynamic includes, I'm not sure if I can zoom a bit, it left its marker comment because it actually did replace the component. All right, yeah, 2 minutes left for the rest of the presentation. That is nice. So that was the walkthrough. Now, obviously, we need to have future plans, right? We basically just started. And I guess you got this point already from the conference, right? The feature model is the next big thing. You heard the reasons why. You'll be able to get smaller Docker images. You will be able to have a more flexible selection. You will be able to have an extension model, so add some features from upstream, get some features from yourself. You can have layering, bring your own JVM, whatever. So it's like now, but much better. We are currently not running on a composite setup, mostly because it's a hassle to set up right now. So what this means is that we have this exact same repository for all instances. Now, the composite node store can give you a much better separation of code and data. It prevents, notably, some configuration races at startup, where some configurations keep being reapplied and restart the Sling repository, which is precisely the reason why I needed to patch Oak, because I was the only one that had that problem. The scripting bundle tracker is another nice step towards separating sort of code and data. Sticky sessions, I mentioned that there may be, sorry, it may be problematic to have sticky sessions enabled, so that's another option to explore. Now, all good things. I don't remember what I wanted to say here. all good things are free. I don't know, all good things come to an end maybe, or that is just a great Star Trek episode. But I am going to leave you with some resources. So there is the Apache Sling Docker image, the Kubernetes documentation, of course. I will add soon a couple of projects that I used, modules to the Sling whiteboard. And the demo that I have used will be here, like the whole Kubernetes Sling setup. It's not in the whiteboard because I keep rewriting history and using tags for demos, so I will completely destroy the history of that repository. That being said, I have 10 seconds, so if anyone has questions, I'd be happy to take them.
Hi, Robert. Just wondering about about the Prometheus exporter. Is that, I mean, there's various kind of exporters of certain, like for example, drop wizard metrics to Prometheus. I found one in the Prometheus, and I think Robust Perception or something like that is the company. They have written one. It looks like we have one. I think we have one in AEM. Is there any kind of commonality between those, or are they just hack jobs?
No, I just hacked one up, to be honest. I was looking for something OSGI enabled a couple of months ago, didn't find anything, so I just...
Right.
Yeah.
It might be worth finding the best one and then consolidate or something like that.
Yeah, absolutely.
Cool. Thanks.
Any further questions? Well, if not, thank you, Robert, for your talk.
Thank you.